asynchronous day out so that you could alternate between the content and your report. So by now you should have picked what field you want to look into, uh, and try to get an understanding of how AI is used in that field. And now you can start to learn a little bit more about the history and maybe find out what's the history of artificial intelligence in the field that you've chosen. So, one of the first examples of AI was Deep Blue in the 1990s beating Gary Kasparov as chess. And it was a bit of a breakthrough because Kasparov beat the first version but then lost to the second program, Deep Blue. And someone who plays chess like Gary Kasparov is very, very good at recognizing patterns and seeing chess related possibilities. The initial version of the software saw it more linear, like, oh, move this pawn forward, then do this with the rook, then make this move. Whereas Gary Kasparov was seeing patterns and seeing several moves ahead. So the next time when they played, when this AI was a bit more sophisticated and had more machine learning of chess moves and chess history, it was able to analyze the board and see more chess related possibilities more quickly. So it was a big headline news when it beat the best best human chess player. So we have some early examples, early video game opponents, auto dialing to telemarket a product, just these basic decision trees, like if this happens do option A, if this happens do option B. And if you want to know what a decision tree is, well, how do you decide how much to tip? So some people would say, was the food good? Yes, I'm willing to tip, or I'm willing to consider tipping. If the food's bad, if it's mediocre, no, I'm not going to tip. Okay, so I got good food at the restaurant. Well, did it take a long time? Yes. Okay, I'll tip. No, well, how do I feel about the total price? Yeah, the price was fair. Okay, I'll leave a tip. No, 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 it still was too high. It wasn't worth it. I'm going to say no. So a decision tree is, where you have a series of possibilities, and they're conditional on events happening. And so that was the example of AI in the 1980s. These very, very basic tasks, or these very basic decision trees. So here's a news story about why Deep Blue improved between 1996 and 97 to beat Gary Kasparov.
The world was paying a lot of attention, and we weren't quite used to that.
Chess events never get covered like that. It was probably the biggest news coverage for a chess match ever.
We were trying to prove that it was possible to build a chess machine that could beat the best human player in the world.
It's also challenging Kasparov in any way. I mean, he's the pinnacle of chess. He's incredible genius.
There were people who, even if just a few years before, said it was going to take decades to do.
The chess world all expected Kasparov to win because the human had always won before.
We worked very hard in the intervening year to improve Deep Blue in various ways.
I spent a lot of time in the office playing a lot of practice games, looking for lots of errors that needed to be fixed.
And we were pretty confident that it would do better.
But then we got to the match. That was the chance to see, did we make a difference?
Gary Kasparov has arrived.
He was under tremendous stress, I imagine. The program wasn't behaving the way he was expecting.
He thought that he was going to figure out the computer.
And he wasn't mentally prepared for it, I think.
I mean, the whole game was surreal. What was he doing? It didn't really make any sense.
Whoa! Deep Blue has instantly sacrificed with knight captures e6.
Deep Blue was just sitting there and just keep on attacking, just moving pieces around. And he knew he was in trouble.
But at the end, Kasparov he stands up He starts gesturing. He looks over at his mother. I think having your mother in the room where you're playing an important chess game is not a great idea, as much as I love my mom.
I was dumbfounded and elated at the same time. I was dumbfounded because I never see him behave that way. He never imagined the world champion and actually somebody I have great respect to be just raising his hand up in surrender.
We demonstrated that there are multiple approaches to solving probably any intellectual problem.
But back then, it wasn't the case. Everybody would look at the computer and say, well, yeah, it's good at some things. It calculates, but it doesn't understand anything.
I worked on this for 12 years. So you can imagine how much energy went into it. When I started, I was like, it was done in 5 to 10 years. I was wrong. It took 12. So I was glad it was over, really.
So another example would be the idea of Watson in 2010s beating Ken Jennings at Jeopardy, and getting the idea of how to play the daily doubles, how to wager, which questions to answer. Understand both. It always knew the facts, but then it wasn't always able to play Jeopardy correctly. Here's an example of when the computer first beat the human champions.
I remember that morning going to the lab, and I was thinking, this is it. This is the last Jeopardy game.
This is Jeopardy, the IBM Challenge. Here we go. Brad, if you're ready, make your first choice.
Let's take alternate meanings for 200, Alex.
4-letter word for a vantage point or a belief. Brad.
What is a view?
Yes.
After the first clue of the game, which Brad won, I had just this horrible feeling at that moment that he was as good as everyone said he was, and he was just going to run the whole board on us.
Watson.
What is shoe?
You are right.
We actually took the lead. We were ahead of them, but then we started getting some questions wrong.
Watson.
What is leg?
No, I'm sorry, I can't accept that.
What is 1920s?
No.
What is chic?
No, sorry. Brad.
What is class?
Class, you got it. Watson.
What is Sauron?
Sauron is right, and that puts you into a tie for the lead with Brad.
The Double Jeopardy round of the first game, I thought was phenomenal.
Watson went on a tear.
Watson.
Who is Franz Liszt?
You are right.
What is violin?
Good.
Who is the church lady?
Yes. Watson.
What is narcolepsy?
You are right, and with that, you move to $36,681.
The risk was, Ken gets a daily double, bets big, gets it right, he's going to be well ahead. And then with that kind of lead going into Final Jeopardy, if he bets enough, he could end up winning the match.
Ken.
What's a committee?
We got to find that last daily double. We got to find that last daily double.
It was a crucial moment in the game. There was still a daily double on the board, and it was starting to become pretty clear that it was in the legal ease category. Let's go to legal ease for 1200.
Watson.
What is executor?
Right.
Same category, 1600.
Answer, daily double.
That was the moment when I knew it's over.
The category is 19th century novelists.
What Watson wants to do then is preserve the lead, not take a big risk, especially with Final Jeopardy, because just like for humans, Final Jeopardy is hard for Watson.
Now we come to Watson, who is Bram Stoker, and the wager. Hello, 17,973, and a two-day total of 77,147.
I would have thought that technology like this was years away, but it's here now. I have the bruised ego to prove it.
My past Jeopardy experiences have been great, but they weren't really weighty with this kind of technological, philosophical importance. I think we saw something important today.
Didn't really think very much about the implications until later and say, wow, wait a second, this is history.
course, this whole project is not ultimately about playing Jeopardy. It's about doing research and deep analytics and a natural language understanding. This is about taking the technology and applying it to solve problems people really care about. We're just so excited about all the things we can do with this.
I had thought this is the end. We get there, we're done. And I'm realizing it's just the beginning.
So the one of the questions that it got wrong in Final Jeopardy on the first day that Watson got wrong, maybe you can answer it. The category was U.S. city, and its largest airport is named for a World War II hero. The second largest is named for a World War II battle. And if you want to pause it to think about this, now, what do you think Watson picked as its answer? Well, Watson actually picked Toronto because of Billy Bishop Airport, who's a World War I hero, and Pearson. Well, the correct answer is Chicago for O'Hare International Airport, and Midway is the second airport in Chicago. So it's our definition of artificial intelligence. It was initially defined by John McCarthy, one of the first researchers, as the science and engineering of making intelligent machines. And the idea is it's software that uses data, algorithm, programming to perform actions, anticipate reactions, and adapt to a variety of situations. And some of the cases we were looking at, Deep Blue and Watson, it's a game. It is for, it was done for entertainment, but the idea is that it takes the learning from playing chess and then learns about something else. For example, a bank using AI to detect suspicious financial transactions and prevent fraud. So you'll find that there are three divisions, and so try to figure out in your field which one of these categories is present. Is it neural network, making connections? That's kind of the basic. It's like, okay, well, Amazon orders a certain number of products based on the postal code, because as a whole, a neighborhood tends to order similar basket of goods together. It doesn't mean you order the same as your neighbors, but if we looked at each neighborhood, that neighborhood would need roughly the same amount of goods each, year. And so it makes that kind of connection. Or machine learning, like analyzing data, such as the medical imaging. Deep learning, and that's more advanced, and that's sort of where it starts to make decisions. It analyzes traffic flow and then switches the lights to make it more flow more quickly. It flags the checkout counter and calls the attendant over. And then we can also use these two terms, and it's based on how much supervision there is. Is it weak? So Siri is supervised problem solving. It just solves the problem that you ask it. There's limitations. Siri is not going to take over your phone and start doing stuff. It's only active when you are. Strong is, there isn't a human supervision. It can teach itself. So Watson was able to start choosing how to, find the double jeopardy. It can you can feed it previous results and say what was correct and what wasn't, and it becomes more accurate over time. So if it's AI where it's given a lot of autonomy, for example, at the Amazon Go store, where the checkout counter is sort of virtual, you grab an item, you go through it, then that is an example of a bit more strong AI, because there aren't a lot of people making sure that the AI does the right thing. So how has it been used over the years? Well, it was Roomba, 2002. It figured out over the course of the day, if you left the vacuum cleaner on, it would trace a path. Eventually, it would cover the whole room. And so that's kind of basic, but it wasn't really precise. You can see these yellow lines were haphazard. It's reacting to the furniture. It's not like it's doing it with any kind of thought. You just turn it on and it ran. By the end it covers it, but it was pretty random. Google began their self-driving car in 2009, but it wasn't until 2014 that the self-driving car could pass the Nevada State driver's test, and then it was split off from Google into its own company a couple of years later. But they're not on the road just yet. So again, that's going to be that kind of deep learning sort of and it's going to be strong AI because it's not really supervised. Yes, there's always during the testing, there's been someone at the steering wheel who can put the brakes on the car, and if something goes wrong. But eventually, if this becomes mass produced, there won't be that human safety feature. It's going to be deciding to make its own decisions about which lane to drive in, where to turn, and so on. And there will not be that human component. Siri began as, again, like the internet came from the Defense Advanced Research Project Agency. This was something that they thought could be used for generals, instead of free up their time by having an assistant do some of the more basic stuff. It was an app that was launched in 2010. Apple was acquired it afterwards, and the idea is it should get to know your preferences and become more accurate. So if you have a different tone of voice, maybe it doesn't recognize it the first time and it said, did you mean this question? Or you can say, no, that was the wrong response. I didn't want to hear that song. And it should be refining its analysis of you and use deep learning to become more accurate. Xbox Connect, using the scanner so that people could play video games, and Wii being another device that sort of uses that. And how does it understand what's going to happen? So we talked about decision trees, which were those basic choices, this or that. Well, decision forests was it kind of would figure out, okay, this person is playing the tennis, and it looks like they're about to hit a forehand, so we'll start moving towards the forehand area of the forest. Okay, now they're in their backswing. It looks like they're hitting it really hard. We'll split. And it already tries to anticipate what's going to happen and put itself in that area, so the video game reacts a lot more quickly to the user's inputs. AI being involved in political campaigns. It's suspected that it was involved in the 2016 presidential election and the Brexit referendum, and it took maybe 100,000 voters in swing states and determined what messages were most popular, what messages were retweeted the most by certain types of people. It categorized them as certain personality types and then funneled messages towards them that they knew resonated with that type of person. And as things got shared more, the AI took that into account and began creating more posts like that. I alluded to this earlier. So Flint, Michigan had water problems, and there were lead pipes leading to water that was contaminated, and there was bad records. It wasn't clear what year which pipes were resolved. And so what they did, but you could sort of tell based on the age of surrounding buildings. It would be likely that the pipes came in the same time the building did. A few other situations, like if they maybe saw a fire hydrant of a certain style, it was probably installed at that time. And so AI was used to identify some pipes that needed to be replaced, and then obviously they would dig it up, test it, and the AI was 80% accurate. However, people said, well, wait a minute, it's AI, you can't totally trust it. What if they're missing the wrong neighborhoods? What if they're not going to, no one's digging up in my neighborhood, they must be missing it. Well, the AI knew that some of these areas, in the red squares, were mostly clean, mostly good pipes. So it was not telling any of the contractors to dig there. So people felt that the AI was, not paying attention to them. So they demanded that the contractor do it by hand, which was, hey, dig it up, see if it's lead, remove it if it's lead, if not, fill it back in. And that's, time consuming. The contractor went to some of these neighborhoods outlined in red and had like a 10% success rate. So that was an example of AI doing an effective job identifying all of these red lead pipes that needed to be replaced, but people weren't really trustworthy of the results. Geico using AI for insurance quotes and a chatbot where you can answer some questions and then it gives you a more accurate insurance quote. You don't need an insurance rate. We know you can figure out the person's lifestyle, you can figure out their exercise, you can figure out their family history and calculate the insurance rate much better than a real actuary. Here's sort of the amount of chat bots that are being used, and you can see, for e-commerce, there's a lot of chat boxes. Banking and financial institutions are big into chat boxes, but even for like healthcare, you go to like it can diagnose what your symptoms are and recommend a course of action. So chat boxes becoming more and more common. Instagram uses AI. It's going to predict what you like based on your likes. It'll show you more of that content in the future. And it's also supposed to be using it to identify and remove offensive posts. Or Facebook's supposed to be using AI to identify people who might be posting suicidal messages. So hiring is difficult, and if you do it wrong, you have to deal with training the bad employee, working with the bad employee to find out that they're unqualified, terminating them, advertising the position again, rehiring, and retraining a new person. So the AI might help people be more accurate, especially small companies that don't hire a lot. So what are the concerns? The ethics. For example, people are concerned that machines will make the right decision. Going back to that medical example, some people just won't trust that a machine can make the right decision. The cost of setting things up. So traffic lights could be managed by AI, and they might be able to have traffic flow more smoothly. But just think of all the traffic lights in Toronto. To set an intersection up as is diagrammed here would add up. Poor decisions. People think back to maybe a computer that they had that would freeze a lot. In Flint, Michigan, AI was used to help with the water that was tainted and identify which pipes needed to be replaced, but people just didn't want to give the machine that kind of power. They wanted a human to go in and investigate themselves. Finding the right partner, that is, which AI company should you deal with if you're an accounting company and you want, which AI company should you partner with? You've never done it before. It can be difficult to find the right sort of financial machine learning company to help your accountants, and sometimes it's necessary to integrate people together. The company that makes the sensor, the company that makes the display that the customer interacts with, the company that makes the processor, having all those come together in a way that makes a coherent a functional product is difficult. So here's another example of once you have to set this up at your store. The idea is at a self-checkout counter like at a Metro or a Shoppers Drug Mart, if you install the camera above, it sees suspicious activity and flags it. What would be the concerns here? Well, what's the cost of setting this up? Is the camera technology expensive? Is it making the right decision? If it was identifying someone who had stolen but they hadn't, or it was missing thieves, if they were, using sleight of hand, then that wouldn't be good. So you'd want it to be cheap, you'd want it to be easy for any of the employees to use, and you'd want it to accurately assess who is stealing and who isn't.
Theft for retailers has always been a big problem. Every time they lose an item, they have to sell 50 more just to make up for the one that they lost.
And many of those losses occur at checkout scanners by cashiers and customers. The National Retail Federation says an estimated $14 billion is lost annually in scan avoidance.
I'm going to pass a few around the scanner or cover up the barcode, do things such that it doesn't ring up.
The scams are brazen.
So the target shows you what to keep your eye on.
As blatant as throwing items down the belt.
These are items left in the cart.
Sometimes accidentally forgetting to scan things.
She should look up the code, but instead she ends up just giving it away for free.
Or customers just getting frustrated at the self-checkout. But intentional or not, now there's technology that spots it as it happens. It's called Stop Lift. Malloy Kundu is the founder.
And when you see these things, you're like, how could someone possibly do that?
Using artificial intelligence, it can read and flag checkout behaviors. Suspicious transactions can be questioned on the spot, and mistakes corrected before anyone is labeled a thief.
Call an attendant over to give you some customer service.
I never expected to find something done purposely.
Miguel Garcia is the owner of Big Deal Supermarket in the Bronx and installed Stop Lift without initially telling his staff.
And I was happy afterwards to see that, in fact, it was mistakes.
Garcia says cashiers now know to look for items on the bottom of carts and even slow down to not miss a scan. He says with this technology, he's thinking of adding self-checkouts.
I think we're actually going to see in helping this theft prevention.
Tech expert Noah Birnbaum agrees this can keep profits in the stores, even passing savings to the consumers.
There's going to be more of this adoption to the technology, and I think that over time we will see less shrinkage in inventory loss.
And the experts say consumers are 5 times more likely to forget to scan an item at self-checkout versus one with a cashier. But
so the idea there is it was actually more of a training issue. It wasn't a matter of widespread theft, but as Miguel Garcia said, it pointed out areas where training was necessary. And when they use the term inventory shrinkage, if you're taking accounting this year, shrinkage is when inventory, naturally disappears, 1 or 2%. For example, at a supermarket, if food goes bad, that would be categorized as shrinkage. If something was damaged, if someone, at Indigo flipped through the book and it was dog-eared and no longer sellable, that would be shrinkage. Or in this case, if items left the store without being sold, they're categorized as shrinkage. And it's usually, there's always a little bit of it, but when shrinkage becomes too much, a business can lose money. Here's how the Toronto Raptors used SportsView, which is a series of cameras to evaluate players and who was in the right position. So it shows the players on defense and where they should have been. The ghost number is the outline number is where they should be, and it compares them to their real position to sort of evaluate how good they are. So then they could go to, say, 17 would have been Jonas Valanciunas at the time and say, look, you're just not in the right position. You're moving too slowly, or you need to step up more. And they were able to give more detailed feedback as a result of this scheme.